Quick question. How does your phone open a website from the other side of the planet in seconds? That's what the OSI model explains. And if you're studying for the Network Plus exam, this model is everywhere. Troubleshooting, routing, switching, security, everything connects back to these 7 layers. So in this lesson, I'm going to make the OSI model make sense without making it feel like a boring textbook. By the end, you'll know all 7 layers, the devices, the protocols, and how data actually moves through a network. Let's get into it. Now, before we memorize anything, why does the OSI model even exist? It's because networks are complicated. Imagine trying to troubleshoot the internet with zero structure. That would be chaos. The OSI model breaks networking into layers, so engineers can isolate problems fast. If something fails, maybe it's the cable, maybe it's the switch, maybe it's the DNS, maybe it's the application itself. The OSI model helps narrow it down. It also allows devices from different companies to work together because everyone follows the same framework. And for the exam, this is huge. Almost every networking concept maps back to the OSI layer. Here are the 7 layers, and yes, everyone memorizes them with a mnemonic. The mnemonic I used was, please do not throw sausage pizza away. That's from layer 7 to layer 1. I know it sounds ridiculous, but you'll remember it during the exam. Please do not throw sausage pizza away. Now don't try to memorize everything instantly, but think of the model like this. The top layers deal with more software and user interaction, and the bottom layers deal with more hardware and moving data physically. And as data travels downward, it gets packaged differently at each layer. Data, segment, packet, frame, bits. We'll build that step by step. We'll start with the 7th layer, the application layer. Layer 7 is the layer closest to the user. This is an important detail. This is not the actual app itself. It's the networking services the app uses. So when you open a browser and go to a website, this layer handles things like HTTP and HTTPS. DNS also lives here, which translates domain names into IP addresses. Email protocols also here. Think of layer 7 as the place where humans interact with the network. No user interaction, no application layer activity, nothing. Now we'll move on to the presentation layer. I'll call this layer the translator. Its job is to make sure that the systems understand each other. This layer handles formatting, encryption, compression, and encoding. An example could be HTTPS uses SSL and TLS encryption here. Image formats like JPEG and PNG, that's the presentation layer for you. So if layer 7 is in the conversation, layer 6 makes sure that everyone speaks the same language securely. Remember that. Now we move on to the session layer. Layer 5, this is the layer that manages the conversations between devices. It starts sessions, maintains them, and closes them when communication ends. Think about a video call. The session layer helps establish that connection and keeps it alive while both sides communicate. It also handles synchronization and checkpoints, so if a transfer gets interrupted, systems know where to resume instead of just restarting completely. This layer is basically the conversation manager. Now we hit one of the most important layers for the exam, the transport layer. Layer 4. This layer is responsible for reliable delivery. It's where TCP and UDP live. TCP is reliable. It checks the errors, it makes sure that it's delivered, but it's the slower. UDP is fast. It's no guarantees, no handshake, but it's lower overhead. So when you're playing video games or streaming, that's when you're using UDP. But when you're doing websites, emails, and file transfers, that's usually TCP. That's a big concept. Another one is ports. Ports allow multiple applications to communicate simultaneously on one device. So layer 4 is all about end-to-end delivery. Remember that. Layer 3 is the network layer. This is where routing happens. Routers operate here. The main protocol is IP. This layer decides the best path for data to travel across networks. Think of it like GPS for packets. It handles logical addressing using IP addresses. And this is where protocols like OSPF, RIP, and BGP operate. So whenever you hear routing, path selection, or packets traveling between networks, immediately think of layer 3 for the exam. Now on layer 2, the data link layer. This layer focuses on local delivery. Instead of IP addresses, it uses MAC addresses, and switches operate here. This layer packages data into frames and helps communicate on the same local network. Ethernet and Wi-Fi both exist at layer 2, and this is where things like VLAN and switching happen. A quick exam shortcut is layer 3 equals routers and IP addresses, and layer 2 equals switches and MAC addresses. Now we move on to the final layer, layer 1, the physical layer. This is where the actual hardware, like cables, signals, and voltage, and fiber optics, and wireless frequencies. The physical layer moves raw bits across the medium. No packets, no frames, just ones and zeros. Devices like hubs and repeaters work here. So if a cable is unplugged or a connector is damaged or signals are failing, that's a layer 1 problem. Now, we have to talk about how data travels through the OSI model. This is going to tie everything together. As data travels down the OSI model, each layer adds information. This process is called encapsulation. At layer 4, data becomes a segment. At layer 3, it becomes a packet. At layer 2, it becomes a frame. And at layer 1, it becomes bits. Then the receiver reverses the process called decapsulation. Each layer strips away its information until the original data reaches the application. This is one of the most important concepts in networking because it explains how communication actually works. Now we will discuss TCP versus UDP. You'll see this a lot on the exam. TCP versus UDP. TCP is just reliable, ordered, connection-oriented, and before sending data, TCP performs a three-way handshake. So remember this: SYN, SYN-ACK, and ACK. It confirms that both devices are ready, and UDP skips all that. UDP, no handshake, no guaranteed delivery. They don't care. Just send it. And that's why we covered this, but it's just gaming and streaming, and then speed over reliability. So remember, TCP is accurate, UDP is not. So I wanted to give you guys this cheat sheet, and you guys need to know these and just have it memorized, know the mnemonics, know the PDUs, know the major protocols, and know the device associations. Router equals layer 3, switch equals layer 2, hub equals layer 1, and memorize all these common ports like port 80 for HTTP, 443 for HTTPS, 53 for DNS, and 22 for SSH. You'll see this everywhere in Network Plus questions, and Network Plus is pretty easy compared to the CCNA, but yeah, this is what you need to know. And that's the OSI model. So it kind of looks overwhelming, but it's pretty simple if once I just broke it down. Just start by memorizing the layers, the PDUs, and the device mapping, and then practice real troubleshooting scenarios, because in networking, the OSI model is not theory, but it's how engineers think. And if you can think just layer by layer, you'll be good for the exam and real world. So good luck studying, and thanks for watching. I'm back, Dota Networking Labs. Subscribe, and I'll see you later. Goodbye.